The last lecture, I introduced the primary concept of synchronous exception. And then I explained it that there are two causes which generate synchronous exception. The first one is memory abort, and second one is system call that was invoked by SVC instruction. In this lecture, I'm going to explain how synchronous exception is generated due to memory abort. So overall, workflow is seen in the slide. If you listen to this lecture, you are going to understand how synchronous exception is generated when the software is running that cause memory abort. So ARM core generate synchronous exception while executing instruction. This is the most important operation when you first running synchronous exception. In case of RIQ interrupt exception or FIQ interrupt exception, those kind of exceptions can be triggered by external event of peripheral device. But in case of memory abort, invalid access to the memory is the main cause of memory abort. So as a result of synchronous exception, the corresponding exception handler for synchronous exception can terminate process or reset the system. So I'm going to explain this operation step by step after this slide. The first step is when process is running, it can access the invalid address. This is the main reason of memory abort. As a result of memory abort, the ARM core will generate synchronous exception. So you may be confused to know in which situation memory abort occurs. It is very important question to understand how synchronous exception occurs in the system. Let me explain about how memory abort occurs in the system. And in order to understand the memory abort, and you need to understand the operation of MMU. MMU stands for Memory Management Unit. Main job of Memory Management Unit is to translate the virtual address into physical address. During the operation, if the MMU cannot translate the virtual address due to various reasons, it may result in memory abort. If your driver code or any kind of software in user application, it can access the invalid address. Access to the invalid address may cause some memory abort because MMU cannot translate the invalid address. And then another reason of memory abort is that sometimes ARM core cannot decode the instruction. Take for example, if the DRAM's external memory is corrupted due to the hardware fault, sometimes instruction may be corrupted. And this kind of things can be called the bit flip, memory bit flip. If there is a problem with loading the proper assembly instruction from external memory, it might cause memory abort because sometimes if the code is corrupted, ARM core cannot decode the instruction. Another reason of memory abort is some of the application try to access the address that is only accessible from Linux kernel. So this is one of the typical example of access permission error. So from software point of view, you may want to know in which code will cause memory abort. I guess most common example to generate memory abort is access the null pointer address. This is the typical example of memory abort. Anyway, if the ARM core cannot access the virtual address, or if the ARM core cannot decode the assembly instruction, ARM core will start generating exception. This is the second stage, the second step of synchronous exception due to memory abort. The third step is most important procedures if you like to understand the workflow of synchronous exception. That is, relevant registers are updated to have some important information at the moment of synchronous exception. Let me explain about this operation in more detail. As a third step, an ARM core will store the value of P state to SPSREL1 register. Since the P state used to have the bit encoding information of exception level, and exception level information can be stored into this register. So this is very important operation because whenever exception is triggered, core will branch to exception vector address.